Today we're going to combine two kind of simplistic sections. Section 6.3 is talking about classifying polynomials, and section 6.4 is adding and subtracting polynomials. So let's get started. The first thing that we need to know is that a polynomial only means many terms. Poly, many, nomial, terms in math. So one of the first things that we need to do is make sure that we know how to write polynomials in descending order of powers. So take a look at this problem. 8x to the fourth minus 11x plus 2x to the fifth minus x squared. Now, each one of these separate things is a term, and they cannot be combined unless you have the same exact variable raised to the same exact power. So the only thing that we can really do with this is pretty it up. We're going to take this and make this look a little bit more mathematical, and we're going to do that by putting it in order from highest power to lowest power. So the highest power that I have is 2x to the fifth. The next power that I have is 8x to the fourth. The x to the fourth is my next power. And you'll notice that the sign in front of the 8x to the fourth is positive. So I'm going to keep this as an addition problem. I'm looking, there's no x to the third. So I'll go to x to the second. Now the sign in front of the x to the second was subtraction, so I have to bring that along with it. It's subtraction. My last term is going to be my x, 11x. This is 11x. It's to the first power. My sign was negative. So look, we went 5, 4, there was no x to the third, 2, 1, and there is no constant. So all we've done now is taken this polynomial, many-termed expression, and put it into order from highest to lowest. So that brings us to talking about how you name polynomials based on the number of terms that there are. So a monomial is a number, a variable, or the product of both. Here's what I mean. A monomial looks like this. Even though there's a lot of letters and there's a couple numbers in there, it doesn't matter because it is joined by multiplication. It's a -3 times A times B. So this is considered a monomial. Mono means one. So it has one term. Monomial, one term. This is an example of a binomial. It has two terms. These two things are joined by multiplication. This doesn't have anything else with it, and the two of them together are joined by either addition or subtraction. Binomial means two. And last but not least, a trinomial is exactly what you think it has. It has three terms: x to the second, x to the first, and a constant. Trinomial means three terms. Before we were naming the polynomial based on the number of terms. Now we're going to talk about classifying polynomials based on its degree. And the degree means nothing more than the highest power in exponents. So we're going to take a look first at this example. This is a first degree polynomial. It's a first degree because my exponent is 1. We also know from experience that this happens to be linear. Remember, for every y we have an x and only one x. This one we know is a trinomial because it has 3 terms. But what kind of trinomial is it? It's a quadratic. It's a second degree. My highest power is 2. So we call this a quadratic equation or a quadratic expression. Next, this is a third degree trinomial, 3 terms. Highest exponent is a 3. That's cubic. A cubic expression is a third degree polynomial, no matter how many terms it has in there. First degree, power of 1. Second degree, power of 2, quadratic. Third degree, cubic. So let's put this together for examples. I'm going to ask you to stop the video and see if you can tell me what degree, what's the degree name, and what's the polynomial name. I'm going to start you off with this first one. This has an exponent of 2, so it's a second degree. When it's a second degree, that means it's quadratic. Anything that has an x to the second power is quadratic. And now I'm going to count, and it's 1, 2, 3 terms. So it's a trinomial. You try this one. This is a binomial. It's a first degree, and first degree equations or expressions are linear. Try this one. This is a third degree. That means it's cubic, and it only has 1 term, so it's a monomial. The name of the polynomial based on the number of terms it has. The degree name is based on its exponent, and the degree is the actual exponent. Now, you know about coefficients. Coefficients are the numbers in front of each one of the letters. The only thing I want to talk about right here is the fact that if there is no number there, then you know that there is an invisible 1. So the coefficient of this x squared is positive 1. The coefficient of this x is a negative 1. The next one I would like you to tell me in order, what are the coefficients for this polynomial? If we were going to name these polynomials, I would look at this and say this is first degree, and it's a binomial. This is a trinomial, second degree, third degree, polynomial, third degree, monomial, single term. This next one is a seventh degree, binomial, and we don't have a special name for something that's a seventh degree. Now, number 6 is a little bit different because these 2 terms can be combined. So before you name a polynomial, what you need to do is combine any like terms. So 6x squareds take away 2x squareds means I have 4x squareds plus 4x's minus a 5. So this is a trinomial that's a second degree, also known as a quadratic. Now, what if we want to add together these 2 trinomials? Notice that there are 3 terms, and all we're going to do is add them together. Well, there are 2 different methods for doing this, and the first one is the horizontal method. And in the horizontal method, we're going to gather up the like terms together, and then we're going to put the terms in order from highest to lowest. Let's see what that looks like. First, I'm going to gather up the like terms. So I have a 6x to the first power and a negative x or a negative 1x that I'm going to put in here. Then there's an x to the second power, a negative 1, and a 4x to the second power. And I'm going to gather those two up together. And last, I have the constants, a positive 3 and a negative 2. If I add up each one of those individually, 6x's take away 1x gives me 5x's. A negative x squared and 4x squareds gives me 3x squareds. And 3 minus 2 equals 1. The last thing that I need to do is put them in order from highest to lowest. And to put them in order from highest to lowest, the only thing I need to do is make sure that the 2 comes the 1, then the none, and put them in that order. The second method is the vertical method. I kind of like this better because this way I can always take whatever the orders are and put them into degree order as I'm rewriting them. So what I'm going to do is I am going to set it up so I use this one first because it's already in proper degree order. So I'm going to rewrite it. 4x squared minus x minus 2. Now I'm going to use this other one and I'm going to write it down, but when I write it, I'm going to put the degrees with the degrees. So x squareds go with x squareds. The single x's go with the single x's. The constants go with the constants. And now I can just add. And already I'll have it in proper degree order. So 4 minus 1x squared is 3x squareds. 6x squareds take away 1x is 5x. And 3 take away 2 is 1. And I already have them that in the degree order. They're going from highest to lowest. You try. Use whatever method you want. This should be your answer. Try this one. Now, just because it has 3 separate trinomials does not mean you don't do it the same way. Notice, however, that there are to the third degree, to the second degree, to the first degree, and constants. And each term doesn't necessarily have all of the same degrees. You should have gotten this for an answer. Oh no! What if it's subtraction? Guess what? The only thing that matters is that you remember that signs are vital. Remember when we had systems and we were worrying about the signs? We need to do the same thing here. So again, when I have something that looks like this, I'm going to make sure that I take this becomes a negative 8. This becomes a positive x squared. And now I'm going to use either method to solve. Get an answer. You should have gotten that. Try these two. First one. The answer to the second one. If you're making errors, it's probably because of your signs. Don't forget that in each one of these, I would do plus, change the sign, change the sign, change the sign. Be very careful with your signs when you're working with subtraction and addition. Right? You're going to work on the two note sheets for 6.3 and 6.4 for homework.